Hi, good day. Let us learn about kinetic molecular theory of gases. An ice cube is solid water, tap water is liquid water, and steam is gaseous water. Most substances commonly exist in only one of the three states of matter: solid, liquid, or gas. However, a substance in one state may change to another state with a change in temperature. You know that when cooled, water freezes to become ice, and steam condenses to form water. You also know that soon after you put on perfume, anyone nearby will be able to smell it. Obviously, the molecules of the perfume have moved through the air. How do you account for these behaviors? A model called the kinetic molecular theory will help you find the answer. The word kinetic refers to motion, the energy an object has because of its motion. This is called kinetic energy. The kinetic molecular theory states that the tiny particles in all forms of matter are in constant motion. The following are the basic assumptions of the kinetic theory as it applies to gases. A gas is composed of particles, usually molecules or atoms. These particles are considered to be small, hard spheres that have insignificant volume and are relatively far apart from one another. Between the particles, there is empty space, and therefore, no attractive or repulsive forces exist between the particles. The particles in a gas move rapidly in constant random motion. They travel in straight paths and move independently of each other. As a result, gases fill containers regardless of the shape and volume of the containers. Uncontained gases diffuse into space without limit. The gas particles change direction only when they rebound from collisions with one another or with other objects. Measurements indicate that the average speed of oxygen molecules in air at 20 degrees Celsius is an amazing 1,700 kilometers per hour. At these high speeds, the other molecules from a hot Chisa in Tuguegarao City should reach Manila in about 20 minutes. That does not happen because the other molecules are constantly striking molecules of air and rebounding in other directions. Their path of uninterrupted travel in a straight line is very short. The aimless path that gas molecules take is called a random walk. This figure illustrates a typical random walk. All collisions are perfectly elastic. This means that during collisions, kinetic energy is transferred without loss from one particle to another, and the total kinetic energy remains constant. The kinetic molecular theory of gases is very helpful in explaining the gas pressure. Moving bodies exert forces when they collide with other bodies. Although a single gas particle is a moving body, the force it exerts is extremely small. Yet it is not hard to imagine that simultaneous collisions involving many such particles would produce immeasurable forces on an object. Gas pressure is the result of simultaneous collisions of billions of gas particles with an object. Gas pressure is defined as the force exerted by a gas per unit surface area of an object. If there are no gas particles present, there cannot be collisions and there is consequently no pressure. Such an empty space with no particles and no pressure is called a vacuum. Air exerts pressure on Earth because gravity holds air molecules in Earth's atmosphere. Atmospheric pressure results from the collision of air molecules with objects. Atmospheric pressure decreases as you climb a mountain because the air layer around Earth thins out as elevation increases. Barometers are devices commonly used to measure atmospheric pressure. This pressure is dependent on weather. The SI unit of pressure is the Pascal. Atmospheric pressure at sea level is about 101.3 kilopascal. Two other units of pressure are millimeter of mercury and atmospheres. The origin of this unit is the early use of mercury barometers similar to the one shown in this figure. Such a barometer was a straight glass tube filled with mercury and closed at one end. The tube was placed in a dish of mercury so that the open end was below the surface of mercury in the dish. The height of mercury in the tube depends on the pressure created by collisions of air molecules with the surface of the molecule in the dish. One standard atmosphere is the pressure required to support 760 millimeters of mercury in a mercury barometer at 25 degrees Celsius. That is, 1 atmosphere is equal to 760 millimeters of mercury, or equal to 101.3 kilopascal. What happens when a substance is heated? The particles of the substance absorb energy, some of which is stored within the particles. This stored portion of the energy, or potential energy, does not raise the temperature of the substance. The remaining absorbed energy speeds up the particles. That is, increases their average kinetic energy, which results in an increase in the temperature. The particles in any collections of atoms or molecules at a given temperature have a wide range of kinetic energies, from very low to very high. Most of the particles have kinetic energies somewhere in the middle of this range. Therefore, average kinetic energy is used when discussing the kinetic energy of a collection of particles in a substance. This figure shows the distribution of kinetic energies of gas particles at two different temperatures. Notice that at the higher temperature, there is a wider range of kinetic energies. An increase in the average kinetic energy of gas particles causes the temperature of a substance to rise. As a substance cools, the particles tend to move more slowly, and their average kinetic energy declines. You could reasonably expect the particles of all substances to stop moving at some very low temperature. The particles would have no kinetic energy at that temperature because they would have no motion. If this is your first time watching my videos, make sure you hit the subscriber button. Thank you for watching.